I think it's only appropriate that it's a windy day in October, on October 9th, October 8th, or whatever day this is, October 8th, 2010. We're on the campus of Clinton Community College in the Stafford building with Scott Buffett. How are you?
Good, and you?
I'm doing great. Calvin and I have always had an interest in wind power when it was just an embryonic idea here in the North Country. And as you might know, Scott, he and I spent a lot of time watching some of those towers being built, from the first holes in the ground and all the concrete footings that were poured right to the very top when they started to turn. And what a glorious sight that was.
Yeah, it's amazing to see the towers go up, huh? Putting the nacelle on top of the towers.
It's just amazing when you see that cell up close and you realize it's as big as my trailer.
Yeah, so when it's sitting up on the tower, you don't really realize that until you see it down on the ground.
Our viewers know, if they watch the programs, that the crane operator had to get a weather forecast from the top.
Oh, yeah.
You know, everything is so precise when you put them together. Did you get to watch any of that construction?
Unfortunately, I didn't get to see any of it, but I've seen videos of it. It's amazing to watch it go up. You know, like you said, you got to have the right wind conditions, and you're trying to build it in a wind park. So, yeah, you got to wait for the time when there's not wind to put it up. So it's amazing to watch the construction of them.
Scott, you and I have never met before. Are you local?
Yep, I'm from Plattsburgh. Graduated from Beekmantown High School and went to school here in Clinton, and then went away to school to SUNY IT.
Oh, did you really?
Then I ended up back here teaching.
Was that a plan from the beginning, or just
No,
pure serendipity? Huh?
Just luck.
Just happened that way.
Yeah, and I started out as an electronics instructor here, and they needed someone with the wind, so I got a few opportunities to train in California and Niskayuna at GE Wind, where they train all their technicians. So it was a great opportunity, and I took advantage of it. So now I'm teaching the program.
We had seen wind farms in many far-off places, including in the deserts of California, visiting there many years ago. And I always said to myself and to anybody else who would listen, Scott, when are we going to get something in the North Country?
Yeah, California started back in the 80s. They had Tehachapi and Altamont Pass, where they started putting turbines. And there was big incentives back then to do it. So for 20 years, they kind of were ahead of us on the wind turbines, but it was nice to see them come up this way now, and hopefully we'll see some more projects going in.
Well, we watched it. We've been to some of the town meetings. We've talked with officials. We've talked with farmers. We've talked with people from the companies that are building them. And we hope to have a lot more in the future, don't we?
Yes, it's a good opportunity for everybody. You know, the farmers make out for having the turbines on their land, and it's great for the whole country because we're generating clean power.
I was thrilled myself to see it happen. And I can't wait until more of them are built, although the whole idea is still somewhat controversial. And I've not had knockdown, drag-out arguments over it, but I'm willing to debate with the knowledge that I've accumulated in favor of wind power, because I'm sure you agree we got to do something.
Oh, definitely. They call it the not my backyard syndrome. You know, everybody wants clean power, but when the turbine goes up in your backyard, it's kind of hard for some people, especially if they're not directly with the project. So it kind of obstructs their view a little bit. But for the whole of the country, I think it's a clean power, and it's good to produce clean power.
You can be honest with me. Are you convinced that it's a good thing, wind power?
Oh, definitely. Definitely we did.
Most of the arguments have been put aside?
From my point of view, that's what, you know, everybody has their point of view, whether they like wind or they don't like wind. But from my point of view, I think it's a good thing. And again, it's a clean source of energy, which we definitely need. And we're definitely consuming more energy as a country. So it's a good opportunity for us.
You know, Scott, there were some very ambitious plans within 100 miles of where we are, back when, before this great economic downturn that we're talking about, to use an affectionate phrase. And then things slowed down a little bit, but we're ready. We're on the cusp. We're ready to move again, aren't we, pretty soon?
Yeah, there's another project being proposed. It's already been It was already in the works, but as you said, the economic downturn kind of slowed down progress on the project, but it looks like it's getting ready to be up and going again.
That's
So
Marble River.
Marble River, yep.
Yeah, that would be a good one. How big will that one be? Do you know?
I think they were talking 70 turbines.
Yeah.
So, it would be good for the area and good for everybody here.
Now, when you were a young guy going to Beekmantown, were you always interested in electronics, technology?
No, it kind of started as playing guitar. I wanted to make little
Oh, here we
effects
go.
pedals.
Another musician. No kidding.
Yeah, and it started with that, and then it ended up being this. So I started out just wanting to make a few effects pedals, and the more I got into it, the more I realized there's a lot to learning what goes into an effects pedal, and then I carried on with electronics.
Isn't that beautiful?
And that led me to this.
Well, from the very beginning, Calvin and I were in favor of the community colleges here in northern New York adopting wind power curricula. And when they announced that they were going to do it here, we all but stood up and cheered like we do for our favorite teams. It's been good, hasn't it?
Yeah, it has been good. I wasn't here for the start of it, but Janice Padula was instrumental in getting the program up and running, and Mark Buckley was the one that was able to get all the equipment here. So he worked with Amatrol and got the equipment here. So yeah, it's been great for the community so far.
That's what community colleges do, and we are so thrilled to see Clinton Community College and the other community colleges here in the North Country and around New York State finally get the credit that we've always said was due them. What would we do without community colleges? And this one up on the bluff outside of Plattsburgh is a perfect spot. Not only that, there's wind up here.
Oh yeah, there's plenty of wind up here, as you can see from today.
Scott, when are we going to put one on the roof here?
We would like to. We're actually talking to one company about putting a small one, but
Are you really?
since this is a historic area, it's kind of hard to put up a larger turbine. So
It's okay with me. We'll hang a few flags on it, maybe dress it up for the holidays. It would be nice to have something up here just to...
yeah, it would be nice. That's kind of what led us to this, because we're up in a historic area. It's hard to get a full-scale turbine, and the cost of a full-scale turbine, you're looking $1 million or more for a full-scale turbine. So this simulates everything that we have in the full-scale turbines, but on a smaller scale, and it lets the students learn the same things that they would see in a full-scale utility turbine.
We walked in here on a Friday afternoon when you have an actual laboratory going. You were setting up before we walked in. How many of these are there available in the country?
Well, this is the first one that they produced. Another college got the other one, but I think we're the first one to be implementing it into our curriculum.
Come on.
So
In the United States?
yeah, this is the first one.
We have a lot of great firsts up here.
Yeah,
This little
definitely.
spot hidden in the Adirondack region. We've seen a lot of simulators in our career as journalists, mostly having to do with airplanes and things. But this is the first, certainly the first wind turbine nacelle learning system that I've ever been. You call it nacelle, right? I always called it nacelle, so I guess I'm way off in the backfield somewhere.
People pronounce it different.
Ha ha!
Some people say nacelle, nacelle.
So why explain the obvious. Why is it so important to have this as a learning tool?
Because it allows the students to work on a smaller scale version of what you're going to find in a turbine. So if you want to look over here, you can
I do.
see
Show me whatever you want to.
we have,
I'm a student.
okay, well, we have our software. I can bring this up. We have a turbine control unit. So as many of you know, these things are automated. They have control units. They need to keep track of wind speeds, direction, ambient temperatures, and then the system temperatures. They need hydraulic systems to run the brakes and pitch systems. Some of the pitch systems are electronic. You can see they turn to face the wind, so they need systems to adjust what we call yaw. And As you can see from this, we have quite a few systems. If we look inside here,
Oh, wow.
students need to learn a lot about the electronics.
Wow.
So we have motor starters, relays, time delay relays, overspeed. This is the turbine control unit. Some of the GEs have PLC, Bachmann PLC units. More relays, over voltage protection. So you can see there's a lot of control units to running a turbine.
I think we should assume that most of our viewers have never seen anything like this before. I certainly never have, except for the real thing. And we should point out in the beginning that there are several different kinds of units, right?
Yes.
You mentioned the GE.
Okay, yeah, the GEs, the ones that you're seeing up in Ellenberg are the GE 1.5. So they produce 1.5 megawatts of electricity. There's other manufacturers, Vestas, Clipper. This one is actually modeled after a Clipper win, but the idea of how these systems work are the same throughout the different turbine manufacturers. So you could probably find 20 different manufacturers of turbines, and I think more people are getting, or more manufacturers are getting into the market now. Because every year they have an WIA conference, which is American Wind Energy, and this year it was in Texas, and there was a lot of new manufacturers. We saw a lot.
Did you go?
Yes.
You got, no kidding?
Yeah, we got the opportunity to go.
What was that like?
A lot of vendors and a lot of people looking to make contacts, and there's a lot of new turbine designs, small turbines, people just trying to make contacts and grow the industry.
That must have been kind of exciting for you.
Yeah, it was
Did you
fun.
go alone or take a staff of thousands? or
No,
what?
Mark Buckley went with me, and Janice Padula, and actually one of the students, Nancy, went this year too. So,
How many other community colleges here in northern New York have this kind of curriculum?
we're the only one in New York.
I want to say that. I wanted you to say that. That's
Yeah.
why we got we're the only system like this.
Yeah,
Huh?
we have the only system.
Isn't that terrific?
Yeah, it's quite a piece of equipment. It's very, it teaches them all the essentials that they need when they get into the large-scale turbine.
Why is it important to have a curriculum like this at Clinton Community College?
Because it helps feed the area with technicians and, train people for jobs in the area. And that's the function of the community college, is to serve the community.
You can't have lived around here for very long without having seen these beautiful big towers and turbines turning. And they're just a marvel to me because they're so big. But the question that's in my mind is, how many jobs can we train these kids for? How many jobs will there be? For example, now your first class is just graduating, right?
Yes, they'll be graduating in December.
Isn't that neat?
Yeah.
How many?
So we have 3 graduating in December. So a small class, so there's the first group got ahead of the curve a little bit.
I like it.
But this job actually involves a lot of industrial controls, as you can see from here, and we might look at some of our other systems.
Sure.
And just because you train for a wind turbine doesn't mean that you wouldn't be prepared for other industrial jobs in the area too.
This is cutting edge stuff, right?
Yeah.
So this knowledge will be valuable for many other things and other kinds of systems in the future. But my question and Calvin's question was, before we started, is will these people who are graduating from this class be able to use this in some way that they can make a living out of it?
Oh, definitely. Like I was saying before, a lot of these controls that you're seeing come from industry. They're not, this system put all together makes a complete system, but each little component is part of industrial controls, motor control trainers, electrical wiring, lubrication. So they'll have skills that will translate into other industries too. Hopefully they'll get a job in wind around here. I know some people want to travel, and there's a lot of jobs throughout the country, so it depends on how much wind we get in this area, new projects, and So
Well, they don't have to travel very far to see other wind farms, because up in the Watertown area in the Tug Hill region, there's pretty good size projects up there.
yeah, there's Tug Hill. Even if you go as far as west as Buffalo,
Yeah.
Noble has 2 sites out that way. So yeah, there's plenty of farms in New York that, besides the ones you're seeing around here.
So New York's been there right from the very beginning, and it seemed like it took so long to get started here in our portion of northern New York. It was frustrating for people like Calvin and myself, not only because we wanted to show it to the public, but because we wanted to learn from it, and we're just so excited by the process. And I'll probably get telephone calls saying, "What are you talking about? You know those nasty things are loud and they kill cows and chickens and birds." But we haven't seen any evidence of that. And as I said, we've gone into the hinterlands to interview the people who have these turbines on their farms, who are thrilled and delighted.
Yes, a lot goes into creating a farm. They just don't throw them up in one day. Like you said, it's a long process. It takes years and years for some of these developers to get these projects done. They got to do site surveys. They have to do studies on birds and any kind of bats in the area. So a lot goes into the research before they build a farm.
We're talking with Scott Buffett on the campus of Clinton Community College on the bluff south of Plattsburgh about wind energy and this wonderful, one-of-a-kind, absolutely unique wind turbine simulator. Now, you had to go to school a little bit to learn this thing, didn't you, Scott?
Yes. Well, like I said, my background's electronics, and as you can see, there's a lot of electronics
here. Oh, you
here.
love that.
And then I was lucky enough, Dan Lance at GE opened up a spot for us to go down and train, so I was able to go down.
How long did you spend down there?
I actually spent 3 weeks down there.
Did you really?
So
intensive.
Yeah, it's 40 hours a week. You stay down there for 3 weeks, and they take you right through their blueprints, and then they spend a week with you troubleshooting, and then another week doing mechanical training, generator alignment, stuff like that.
I want to let people know that we're going to show a complete news conference at the end of this, where you demonstrate this to the public, and it seems to me like the public officials and the public seems to be embracing this whole concept now. That wasn't always a foregone conclusion, but as I said, I think the worm is turning now.
Yeah, and people are seeing them up in the area. They're seeing, the positive of producing clean energy. A lot of talk about green jobs and the green economy and all that stuff. So I think the whole country is sort of leaning that way towards green, energy efficiency and clean energy.
You don't have to explain every nuance of what you teach here, but give us a general idea what somebody who wants to sign up for this class might expect during the course of study.
Okay, well, we take them through DC circuits, AC circuits, some industrial electricity. We have 4 wind-specific classes. So we have a mechanical class, we have a power generation, a troubleshooting, and a intro to wind. So they learn a lot of different skills. Meteorology, so you need to be able to forecast the weather.
Absolutely, and that's vital.
Yes, definitely. So it's a good curriculum. They learn a diverse amount of subjects, and English, math. So we take them right through everything.
And now there are new, smaller turbines, and people are able to erect fairly dependable turbines in their backyard if they got the space to do it. In the beginning, the technology was a little bit tenuous, and we know people who wanted to be so green, they put these things up, and in the wintertime they were breaking legs trying to climb the towers and get them fixed, but it's getting better all the time, isn't it?
Yes.
Even for the homeowner.
Yes, there's a lot of manufacturers. Bergey's one I can think of that's a small wind manufacturer. And they've had turbines out there for quite a few years now, so the reliability is getting better. And as you drive around town, you can start to see some small turbines around town.
I love it.
Yeah.
I mean, I was brought up in the age of the little Dutch boy that put his his finger in the dike. You know, remember all those great big windmills.
Yeah, the windmills, the four-bladed windmills that were used more for grinding stone or grinding grain and stuff like that. And that's kind of the, you know, the beginning of all this. So they went from grinding grain to producing electricity. So that's why we call this a turbine rather than a mill,
Yeah.
because it's not milling anything.
But for me, it seemed like a natural thing to do. This wind is out there.
Oh, yeah.
Especially today as we're doing this, and Calvin assures me that it's the 8th and not the 9th of October 2010. We had some nice little brisk windage out there that knocking the leaves off the trees at about 20, 25 miles an hour.
Oh, yeah.
So this area, there are some parts of Clinton, Essex, and even Franklin counties that have pretty good constant wind, and that's a necessity, isn't it?
Oh, definitely. You can look online. If you look up, there's wind maps, and they read, you know, what the wind is in different areas, and they show you where's a good spot to find wind. So if you're looking, say, you live in a certain area, you want to know what your wind resource is, you can look at these wind maps and find out where the best wind is.
Do you take your students on site outside the college here and on site for where any of these turbines are located?
We haven't gone to the turbines, but what we did do last year is we went down to GE where they have their training facilities, and we went for a tour through their training facilities. In their facilities, they have 3 turbines on the ground.
Oh, they do?
In a lab, yes, and they have the hubs, and they have everything so they actually get to see everything that is there before they actually get
So
in.
this whole thing is even while you're teaching this, it's a real learning experience for you, isn't it? 'Cause
Oh,
you
definitely.
are, as I said in the very beginning, you're right on the cusp of this thing, and there'll be new technology being developed every year from now on.
Yep, the technology changes as they get more reliable and they get bigger. As you notice, each project, the size of the turbines go up, and they start to implement new technology, some direct drive systems, which gets rid of the gearbox.
Oh,
So some reliability issues have been with gearboxes, so some of
Yes.
the companies are starting to look to getting rid of the gearbox.
well, what I seem to remember when we were down there with Noble that they said there was something like a 20-year lifespan. Is that right, or is that wrong?
Yeah, they're designed for 20 years. They might last longer, but when they engineer the thing, the minimum they want out of them is 20 years.
Explain this to some of our viewers, some of the things that we've talked about with the other engineers in the past. How much wind do you need to make one of these things viable?
It depends on the turbine design, but they have a power curve. And actually, I can show you on the software. Usually
Sure,
about
anytime.
4 meters per second, they'll start to kick in. And then there's a speed where you want it to shut down because it's going too fast. And they use meters per second, so 25 meters per second you want it to shut down. And I can actually
Oh,
demonstrate
yes,
that with
please,
this.
please do. Yeah, that's what we're here for.
Okay, so as you'll see later, this demonstrates our wind. So right now, sorry,
That's all right. Don't be sorry. Do it.
our nacelle is facing away from the wind, so the fan's blowing on the other side of our anemometer up top. So, clear my alarms. Now right here we're reading our wind speed. So according to what I have the fan, it looks at about 20 meters per second. And we want that to maintain for 2 minutes. So if we get an occasional gust, we don't want it to just start up all of a sudden. So
I see what you
we
mean.
take
Yeah,
a 2-minute
sure.
average of it.
This is also Star Wars for me. It's
Yeah.
amazing,
So
but I
as you
love
can
it.
see, the turbine starting to turn to face the wind. So they refer to that as yawing into the wind. And it's in a wind sense mode, so it's just reading it, facing the wind, getting ready to start. Ramping up power. Okay, so now it's running in the automatic mode. What happens if the wind gets too fast? So I'm just turning up the fan,
Okay.
and now we're looking at 27 meters per second.
Oh, wow. I'll hold my hat.
So, yeah, it's really gusting. So once it maintains that for a little bit, it will shut itself down.
Can you tell us that in mph?
Is it mile? You're doing it in meters?
Meters per second.
And how about
A
mile
lot of
per-
I'm not sure of the conversion rate off the top of my head.
You
usually
can't
talk
ask him that
meters
many
per
hard
second.
questions. We're just not used to the metric system, and I don't know if I ever will be.
Yeah, a lot of things are metric because a lot of the industry came from like the Danish,
Oh, sure.
where the
Absolutely.
early windmills were. They were one of the first ones to design the early turbines.
Does this simulate everything,
Um,
pretty much?
It gives it, yeah, most of it. You can see we have different software tabs. So we have, all these are digital ins. It's showing what's on. Our digital out shows what's on right now. So we have a nacelle fan motor on and a rectifier fan motor. It gives us different tabs, raw data, totals, our generator, pitch. There's actually another part of this system that we haven't purchased yet, and that's the pitch controller, which emulates the blades.
Oh, really?
Yes.
All right, let's go out. Let's collect some money and go out there and get that set up for you. Are they thinking about it?
Yes, they're trying to get some grants to do that, so that'd be great if we had both the nacelle training and the pitch training.
Now, does the college have to actually go out and recruit students for this program? Do you get personally involved in that, or is there a waiting list, or what's the deal?
There's not a waiting list. They're always recruiting students, you know. The college is always
for the WIN
recruiting for the
programs,
program.
hopefully this program will help to do that. The news conference that'll follow our interview will do that.
Yep, so that's part of our recruiting, you know, letting people know that the program's out there. And right now there's no waiting list. You just have to come in, take a test to see where you are for your math skills and English skills, and then you can start in the program.
You know, we're great fans of community colleges because it's a reasonably inexpensive way to get a fabulous education and to find out what you might be suited for in the future. Many of the credits gained at community colleges are completely transferable to four-year schools. And, you know, I don't have to spend a lot of time talking about it, but we've been so proud of Clinton Community College up here in the Bluff for so many years. And this is absolute proof of the value we have for this community.
Yes, it's definitely a great way to get started. Like you said, the credits transfer. So, you know, maybe do your first 2 years here and move on to another college. I did my first 2 years here and went on, and they transferred almost all my credits. So
that's wonderful.
great.
Now, I have guests in town this weekend. My daughter and her husband from Long Island. When people come to town, I say, get in the car. We bring them up here in the Bluff because my daughter Barbie got a 2-year nursing degree here many years ago and has been a very successful critical care nurse on Long Island for many years, so she loves to come back. But then I take these people to see the wind turbines and the towers, and it's amazing. And the first question they ask is, how come that one's not turning? How come none of them are turning? It looks like there's enough wind, but there are reasons for all of that.
yeah, it depends on traffic on the grid. The power authority tells them, you know, how much power they can take from the wind farm, so they're restricted by how much need there is for the electricity. So the power authority allows them to have so many turbines, and then the other ones they might have to shut down while the other ones are producing what they need.
That's a factor for discussion, and most of the wind power that we have is collected in this area and sent far away from here, right?
I believe it goes up to Messina and then back down to Utica as the main hub for all the power lines. So,
you know, some of this is purely philosophical, but a lot of it is practical. And we learned in a great blackout that happened in the Northeast when you were just a very, very young person that we need to do some work on this national grid, don't we?
oh, definitely, we need some improvements on the grid. that's with wind in general. There's most of what constrains wind from growing are grid constraints. So, like in the Midwest, you have these large open plains with wind resources, but you don't have the grid in order to put them to where people live on the coast. So that's one thing that government's working on, is to build the grid out.
I wouldn't be surprised if you will track the careers of your young students, including the first trio of graduates this wintertime, and see how they make out getting jobs and so on in the future. That'll be nice to know, won't it?
Oh, definitely. Well, it would be great to track how they make out after they get out of the program. It being a new program, it's hard to know the outcome, but hopefully they do well,
Scott, is there anything else about the simulator that you'd like to tell us before we move on and look at some of the other equipment?
Like I said, it just emulates all the systems that you find. The brake, so I can show you the brake, the rotor lock, the hydraulic manifold, accumulators that accumulate the pressure in the system. This down here shows us our gearbox. So you got to keep the gears lubricated. So you need a pump. You want to keep the oil clean. You got a filter, keep it cool, and then circulate it back into the gearbox.
And the gearbox is eliminated in some of the newer designs, you told me?
Yeah, and some of the newer designs, they go with a direct drive. So they have a bigger generator, and they switch on different poles in order to match the frequency of the grid.
Is that a good thing, you think?
It's good for the reliability, yes, but you need a bigger turbine. So that's the catch.
Well, there is a considerable distance between the tallest of these towers and the shortest ones,
Yes.
and the length of the blades. Why is that? I mean, the biggest ones are, how tall are the biggest ones, would you say?
You mean around here? Or
Yeah, around here.
everything around here is actually a 1.5.
Oh, it is?
Yes, they're all the same size, but they might be different height on the tower. So, and it could just be a vantage point kind of thing where you're looking from a.
I know
you're
they're real
closer.
big when you're standing at the base and looking up, and Calvin was getting his neck craned really good when they were putting that nacelle on top that one time. And we've seen those blades on the ground,
Yeah.
and we've seen parts of these things going down the road, and that's interesting all by itself. So the towers are how tall are these towers, would you say, the ones closest to us?
I believe about 250, 275
Yeah.
feet in the air.
You might get a strange feeling if you were standing on the top, Calvin. But some are shorter, the ones away from here.
I think there's a couple that they shorten the towers on, but I think in general they're about that height.
Do you think we're beginning now to settle on what might be a design that lasts for quite a long time? We've done a lot of experimenting over the last 10 years.
I think they'll always change no matter
Yeah,
what.
that's true of
You're
any
always trying to get the most out of
Yeah.
each turbine. So even some of they were talking about even some of the 1.5s, they're trying to overspeed the generator a little bit and get a little more power out of them. So
Of course, Scott,
it's always changing.
yeah, the naysayers are saying, look at the problems they've had so far. I mean, considering how many turbines there are in the world and how few accidents there have been, I think the track record's not very bad.
No, it's not bad at all, and I think they're learning from any accidents that might have happened. They're learning from that. They're investigating it and finding out the problems and making them better every day.
There's so many electronics and so many working parts. It's amazing to me that they last more than 2 weeks once they start spinning. Those are some great forces at work.
Yeah, they have a lot of good engineers working on all these systems. And as you can see, there's a lot of systems inside the turbine, but they're very automated. A lot of them can be run remotely. So.
Well, it's important for our viewers to know that they may not be seeing this within a few days or even a few weeks at the time we're recording this in fairly early October 2010. So when did the simulator get here?
It got here towards the end of summer.
Oh, it did?
Yeah.
So it's a relatively new thing.
Oh yeah, it's new this semester, so.
It's not a bad teaching tool, is it?
No, it's been great so far. It's been pretty reliable. We have lab exercises to go, and we're developing stuff all the time with it. So as we go through, we'll find even more
I didn't ask.
activities we could do. with
Yeah,
it.
I didn't ask you how long is the program? 1 semester, 2 semesters,
It will take you 4 semesters to complete the
4
program.
semesters for the entire program.
Yep.
And so we're cranking out the first 3. And what does it look like for next semester?
I'm not sure on the numbers. I just moved over to this job.
Oh, you
I believe,
did?
Yeah, I believe it's about 12 for the next cohort of people.
I wouldn't be surprised in the not too distant future that they're standing in line at the door, banging to get in. It looks so exciting, and if I were much younger, I would be standing there waiting because it looks so intriguing to me.
Yeah, it's a fun program. There's a lot of hands-on stuff. I know a lot of people are kind of scared of book work, but you know, you get through the book work and towards the end you get to do all the fun stuff, playing around with the simulator and motor control trainers and wiring and all that stuff. So yeah.
It's absolutely terrific. So what else have we got to see in here?
Okay, we'll take a look over.
We'll shut it off a minute and move to another spot,
Okay.
all right? We're talking with Scott Buffett about wind power at Clinton Community College. We moved away from the simulator, and you have other pieces of equipment that you teach with.
Yeah, this piece of equipment here is our motor control trainer. And what it does, it teaches them about the individual components. Where on the turbine nacelle trainer, you've seen the whole system. They work on the whole system. With this, they learn each individual component and how it works. So when you go to troubleshoot it, if you have an understanding of how the component works, it makes it easier to troubleshoot.
Scott, as a last question, but I think a vital one, what requirements would it take for a student to matriculate into this program? What would they have to do ahead of time to get ready for this?
One important thing is to have the math skills. We determine that through the placement test. But if you have your math in place, you'll be all set to come right in and start working on it. As far as background, we get a diverse amount of background, so we'll teach you everything you need to know, kind of thing.
Oh, I like that. We'll teach you everything you need to know. I want to thank you for spending a little time with us, for getting involved with the program. North Country boy makes good. Is this the end of the line for you, or do you have other aspirations, or what do you think you're going to do with your life after this?
Well, I just started in this program, so I'd like to stick with this for a while.
Okay.
You know, get the program up and
We'll come
built
back
up.
we'll come back when you're old and gray, and still, if you're happy with it. You've done well so far. It's nice to inspire young people to do good things, isn't it?
Oh, definitely. It's, feels good to help people out and, teach them. Teaching's great,
And it speaks well for young people in the North Country. We hear so many negative things via the mainstream media, as they say. It's nice to say nice things about young people, and you're still a very young guy yourself, so I'm sure you can identify with a lot of your students.
Oh, yeah, definitely. Like you said, a lot of the media focuses on the bad things. Well, you come up here and you see all the good things that young people are doing in our community, learning about this stuff,
And it's very possible that those first 3 people who graduate and others will not have to move away from here to make a nice living in the future. Wouldn't that be neat?
That's the hope, to be able to stay around here and contribute to the community and, stay where they're comfortable. It's nice to have people stay around.
I know you got a lot to do. We burst in right in the middle of a lab that you had going on today, and we'll let you get back to your students. Thank you so much. Congratulations, and good luck in the future, Scott.
Okay, thank you.
Thank you.
Press conference.
And the press conference, you will see, will explain this whole thing to the public, hopefully in terms that we haven't covered, but we don't mind if it does. So thanks again so much. Thanks to you guys, too, for being in the background, for being... We don't know who you are, but some of your faces weren't hidden through the course of this program. Thanks again. Now enjoy the news conference and celebrate wind power.